Hello and welcome to IoT Boot Camp Day 3. Today we're going to be discussing integrating devices with your IoT infrastructure using endpoints, ThingPoints and edgeware. My name is Craig Chapman. I'm a software consultant for Embarcadero Technologies. On the screen you can see my email address and my Twitter handle, as well as a link to my blog and a link to the blog page which accompanies this session. Any links or URLs I provide in this session will be available on the accompanying blog page, as well as the source code for the projects that we build. Most of the projects that I'm going to be building today you can follow along with using RAD Studio, Delphi, and the RAD Server developer license. At the end of today's demo, however, I'm going to be connecting a physical Arduino device to a Delphi application to collect data. If you want to follow along with this last demo, you'll need the MakerFab's Arduino developer kit, which accompanies the IoT Boot Camp. I'll also be using Visuino Studio from Meetup Software and the Megalabs component from Meetup Software. So today we're going to discuss endpoints and how to build endpoints using EMS modules. In order to do this, we have to describe what an endpoint is and have a brief discussion about REST services. So we'll start with some terminology, discuss what a REST service is and what an endpoint is, and then we'll go on and build an endpoint using Delphi. After this, we're going to talk about edgeware using ThingPoints. Edgeware is software which allows you to attach devices to your service-oriented architecture application. So we'll discuss what edgeware and ThingPoints are, and then we'll go ahead and build a ThingPoint using Delphi. In tomorrow's session, we're going to build on the components that we construct today, adding YAML documentation and accessing the endpoints and ThingPoints from other languages such as JavaScript and C#. So first up, what's a REST service? Well, REST is an abbreviation of representational state transfer. It's effectively a protocol for interfacing with services over the internet, on the cloud, wherever they may be. And the idea behind REST, the predominant driving idea behind REST, is that there is no state kept between one call to the service and the next. So each call to the service doesn't need to maintain a session or a cookie or anything like that. It can just make the relevant request. Although REST services don't have to be based over HTTP and HTTPS, they usually are. It's become something of a de facto standard to provide representational state transfer over HTTP using the HTTP methods as synonyms for CRUD methods. Generally, if you hear someone describing a REST service, they're talking about a HTTP service, and they're probably also mentioning JSON, because usually JSON is used as, again, a de facto standard for REST services. JavaScript stands for JavaScript Object Notation and is a human-readable text format for encoding data. This forms the data transport protocol between a client and a server in a REST-based service architecture. So what's an endpoint? An endpoint is the entry point to a service or process in a service-oriented architecture. Or, for our purposes today, an endpoint is a URL. So if we take a look at the two example URLs, which are EMS URLs for a locally hosted EMS server, we can see that the only difference between them is the end of the URL, where we say version or API, and that is an endpoint. That is the location at which our service is available. Sometimes a URL plus a HTTP method is referred to as an endpoint. So if you consider the version endpoint that we looked at a moment ago with the get method added to it, the HTTP get method corresponds to the read operation in a CRUD setup. So effectively, the endpoint URL plus get could be considered an endpoint of its own in that it provides a service to read data. And then the post method to create new records could also be considered a separate endpoint. This terminology is actually less frequently used, but you may come across it. I prefer to think of an endpoint as the URL and the methods as operations on that service. Okay, so the first thing we're going to do is to build an endpoint of our own. And what we're going to do is build an endpoint which exposes a data table from an interbase database. So let's go ahead and start building that project. So I'm going to go ahead and do File, New, Other, and I'm going to select EMS under the Delphi projects, EMS package. I'm going to create a package with a resource. So this is going to be an endpoint that returns some data. And I'm going to call this employee. To keep things simple, I'm not going to go for a data module. I'm going to go for a unit. I'm only going to be implementing the get and get item methods. And I'm going to go ahead and hit finish. And the RAD Studio IDE has generated an EMS module project for us. Now, I have built this project once before, so I'm going to go ahead and save it over my existing project. So let's do save all. And for the unit, I'm going to save this as endpoint.employees.pas. And for the project, I'm going to name it EMS employees. So when you come to the subversion repository for this session, you'll be able to download the project called EMS employees and have the source code for this project. Okay, so we have an endpoint and it has two methods, get and get item. And this is for getting all records in the dataset and getting a single record in the dataset. So since we're talking about a dataset, we're going to have to connect up to a database. Now, RAD Studio ships with a sample database called employees, and that's the database I'm going to use here. So I'm going to go ahead and put in the FireDAC users list, which I'm pasting in because it's quite a lot of typing there. So this is the standard FireDAC units and the drivers for interbase, so we can go connect up to our sample database. I'm now going to build a method which will connect to the database and run a query against it. So I'm going to call this function t employee resource dot, let's call it database select, so db select. And I'm going to put a parameter in here, an empno parameter, so that's going to be the employee number, and I'm going to make that a string, and I'm also going to default it as a nil string, so we're basically saying we could omit this parameter. I'm now going to say tJSON value as a return type, so we'll be returning a block of JSON data that we can return from our endpoint. Okay, so Control-Shift-C to put that method into my class header, and it copies the method but doesn't fill in the default, so let's put that in. Okay, I'm connecting to a database, so I'm going to need a couple of things. I'm going to need a connection component, which is a tFireDAC connection, and I'm going to need a query, so that's going to be a tfd query component. Let's start by building the connection. So we'll say connection is a tfd connection, and I'm not going to make it, I'm not going to give it ownership because I'm immediately going to dispose of it when I'm done. So I'll manage the ownership of that myself. And now we need to connect this, connect to database. So we need to connect it to our database. Well, that means setting certain parameters. So we'll say params.driverID, and the driver I want is IB for interbase. Params. There isn't a server parameter, so I'm going to add this manually. This will be server, and the server runs on my local machine, so I'm going to put in the loopback address there. What else do we need? We need the database name. And this is quite a lengthy path, so I'm going to go ahead and copy paste this from my previous code. Now this path will be the same on your system as it is on mine, so long as you installed the samples into the default directory when you installed RAD Studio. You get the Interbase Database Developer Edition and this sample database with your install. So now I need a username to connect to that database. Well, the default username for all Interbase databases is sysdba, and I'm also going to need a password. So the default for all Interbase databases is master key. Always be sure to change your defaults. Okay, now when we attempt to connect to this database, it's going to try and pop up a login prompt in the UI for us as just a convenience of the connection class. I don't want that to happen, so I'm setting connection.loginPrompt to false, and then I'm going to set connected to true. Now, if this connection fails, we can check that by saying if not con connected. And we want to do something if it fails. And what I'm going to do here is return out of the function. Now, as I exit the function, at the moment I've not initialized the return value. So I'm going to go ahead and initialize that now as nil. So what that means is if the connection fails, we're going to return from this function, and we're going to type connected very badly there. Okay, we're going to return from this function, and we're going to pass out nil. So by checking the return value, we can tell if something went wrong. Okay, so the next thing I'm going to do is actually build up the query for the database. And we're going to do that by saying QRY is tfd query.create. Again, I'm not going to set the ownership for this class because I'm disposing of it myself. Okay, and then we need to fill out the query with some SQL. Actually, first we should connect the query to our connection. And now we want to fill out the SQL for it. Now, because I'm passing in an optional parameter of the employee number, I'm going to need two queries. So, if empno is a nil string, then begin. If it's a nil string, we want to return all rows from the database. So the query SQL text will be select star from employee. Okay. On the other hand, if we pass in an employee number, then query.sql.text is going to be select star from employee where, and then we want the employee number column, so that's empno, and we need a parameter. I'm going to give it the same name, and that's our query statement there. Now in this case, we need to pass in the value of that empno parameter. So I'm going to say query.params.param by name, and the parameter name is empno, the same as the field name. And I'm going to set it as a string because I'm passing a string into dbSelect here, and the string that I'm passing in is empno. So that's going to set the conditional parameter for us there. So now we want to set the query to active. And what this will do is execute the query against the server and activate the cursor that's going to allow us to step through the result set. Now we need to check that we actually did get some results, so I'm going to put two checks in here. I'm going to say if not query active. Why can I not type? There we go. Then begin, and we'll exit. So basically, if the query does not go active because we're not connected to the database, maybe the connection dropped between creating the connection and creating the query, then we're going to exit and we're going to return nil. So we're not really returning much error information, but we are returning the fact that there is an error by returning a nil result. And I'm going to use the same return for if query dot, is it record count or row count? Record count. Yes, if query record count is 0. Actually, I'm not going to do that check. If the record count is 0, I want to return an empty data set, so I'm going to leave that out. Okay, so now we're going to return results. So finally, we can set the return value, which is result, and I'm going to pass back a tJSON array. An array because each entry in that array will represent a row of the database. I'm also going to set the query to the first record before setting up a while loop to go through the query and say, well, the query is not at the EOF. Short for end of file. I don't know why it's end of file and not end of record set, but it's just the way that it is. So, while the query is not at the end of the record set, we are going to, well, we need to create a new row in that array. So I'm going to say row equals tJSON object.create. That means I need a variable up here called row tJSON object, and I'm creating an object for this row of data. And then I need to copy all of the field contents from the query into the JSON array, the JSON object. So I'm not going to make you watch me type all of this out, but what I will do is just show you the first one. I'm going to say row.add_pair to add a JSON pair, and this is a name value. So I'm going to go with the emp number field because we've seen that already, and I'm going to pass that in from the query field by name. The field name is empno, and I want that as a string, and so that is my JSON pair that I'm adding in here. I'm going to go ahead and fill out the rest of these fields, and I'm going to fast forward this recording until I've done that. Okay, so I've added all of the fields from the database into this JSON object, which is the row. I'm now going to add that row to our result array set. So tjson array result. So I'm typecasting the result as an array. The reason I'm doing this is I created the result as an array here, but the actual type of the result is a tjson value. Tjson value is a base type which is used to derive tjson object, tjson array, and several other entities. So I can pass back any entity from this function, and I like keeping the header that generic. But internally, I'm going to cast that as an array because that's what I'm actually sending back. I want to add to that array the row that I just created. And finally, so that we don't end up in an infinite loop, I'm going to set query.next, which will skip to the next record. So this is going to keep skipping to the next record until we get to the end of the record set and the while loop breaks out. When the while loop does break out, result will contain our array with all of our rows added into it. So that's our method for fetching data from the database. So now let's go ahead and see how we return that from our endpoint. Well, let's look at the get method first. So get is intended to return all records from the database. So I'm going to come down here to get, and we need to change this code out. As you can see, the sample code already turns a JSON string. Well, I'm going to swap that out for our JSON object, which is dbSelect, and we don't pass any parameters in. So dbSelect, the method we just wrote, is going to return a JSON array, and that's what will get returned back. So let's take the same code again. And we're going to repeat this in getItem. The difference is that the code for getItem actually requires a parameter. So we need to pass a parameter in here. And the important thing to remember is that a endpoint in EMS is effectively still just a HTTP request response service handler. So the parameters that we are sending in our request come in through this aRequest class, and what we're sending back is the response. Okay, so I'm going to go to the request class, and I'm going to grab a parameter, and I need to give the parameter, let's go values, parameter values, and I need to name that parameter. I'm going to say item. Now we won't, as you will see, we won't actually need the item tag on the request, but we'll get to that. So basically what this is doing is it's saying, get this parameter that's being sent up from the client when making a call to this endpoint, and use that as the employee number into our dbSelect. Okay, so with a little look, this should build and run our EMS server. I'm going to import all of the FireDAC libraries, and there we have it, the server running. If I open the results in a browser, I'm going to go ahead and drag this across so you can see it. So we have the EMS version tag coming back. Let's change to our employee endpoint, and we're actually getting an empty record set, so we've got something wrong there. So let's go and see what's going on here. Well, I guess it's time to do a little debugging, so I'm going to hit a breakpoint, and let's go ahead and call that endpoint again. So I hit my breakpoint. I'm going to step into dbSelect. We're setting the result to nil. Connecting to the database. Connected is true, so that's working. Here's our query, and we'll select star from employee, set that active to true, and active is true. We're creating a JSON array to return. Okay, and we are somehow at the end of the table. Very silly mistake, that should have been a not. Okay, so let's test that system again. And we can see that the browser has already called and brought our data set back. I'm going to go ahead and refresh that just so you can see the data coming back. Okay, so we also have a second method, which is to get an item. Now what we're actually going to do, I'm going to put in the number 5 on the end here to get employee number 5. You'll notice that I don't need to put in item equals 5, I'm just passing in the 5, and that's getting the item, so that's our parameter going up. So at this point you might be wondering, how did I know that this parameter was called item? Well, if we go back into the code, step up to the top here, you can take a look and we've got some attributes being assigned here, and one of the attributes is item. So effectively this resource suffix is telling the endpoint code that the parameter item is going to be passed up, and that parameter is being passed up as an extension on the URL. So that's how I knew that the value I needed to get down here was named item. That comes out of the default code that's generated when you create the endpoint. So in tomorrow's session, we're going to look at how we add YAML documentation to this endpoint, and we're also going to look at how to access the data on this endpoint using a third-party development tool, maybe using JavaScript or something. But for right now, let's see how we can access this endpoint using Delphi. Under the project group, I'm going to go ahead and add a new project, and I'm going to select a multi-device application. Blank application, OK. So what I'm going to do here is I'm going to go and get a REST client connection. I'm also going to get a REST request and a REST response. I'm going to go ahead and take the client and set the base URL here to point at our EMS server, which is on HTTP localhost port 8080. And then for the request, we're going to request the employee endpoint. So I'm first going to make sure that my REST client is bound to the request, and then I'm going to set the resource here to employee. And finally, on the REST response, we need to make sure that the request is bound to it. So I just check the response property here. Now, if I go ahead and start the employee's endpoint project, that's going to fire up EMS server. So we know now that our endpoint is running, and we can see it in our browser as we did a moment ago. And there's our data. So I'm going to go ahead and execute this REST request in our designer, and I get a 200 OK. And what that means is that the data from our REST endpoint has now been brought back into our response component. So if I take a look at this, we can see the content length here. We've got 9,000 or so bytes. And if I click on the ellipses here, I can see our data coming back from the endpoint. So now we've got data coming back, let's go ahead and display it. I'm going to bring in a FireDAC REST adapter. So it's a T REST response dataset adapter. And I'm also going to bring back a FireDAC mem table, so a memory table. And what I'm going to do is I'm going to get the data from our REST response into our memory table, and I'm doing that through this adapter. So I'm going to select the data set as the FD mem table, and I'm going to select the response here as response 1. So that's now brought the data through into the mem table, and we can see that the mem table is active, which means the data is in there. So let's see about displaying some of that data on the form. I'm just going to go ahead and put a string grid on our form. And if I right click on the string grid and go to live bindings, or rather bind visually, we get the live bindings editor here. And we can see the mem table with all of our fields already in it. So I'm going to go ahead and bind our fields one by one into this string grid. Okay, so you can see that a bind source and a bindings component, binding list, has been added to our form, and that contains the data for these bindings that we've configured. And our string grid is already displaying the data. So let's go ahead and expand that out so we can see a little more of it. In fact, I'm going to go ahead and set the alignment to client so that that fills our form and we can stretch the form to see the data. So if I go ahead and run this application now, we'll see that there's actually no data provided in the application when it runs. The reason for this is We executed this REST request in the designer, but we haven't done that yet at runtime. So I'm going to go ahead and select my form, and on the events, I'll take the onCreate event, and I'll do REST request1.execute. Now when I run this application, we should see the data from our endpoint. Great. So now we can gain access to our data using a Delphi application. I'm going to go ahead and save this application off, and in the subversion you'll find it as EMS Employees Client. Okay, so let's talk about what a ThingPoint actually is. So far we've seen that we can have an EMS server with various endpoints running on it, and it could be connected to by various EMS clients. Those clients could be desktops or laptops or tablets, and that allows us to get data from a database stored locally on the EMS server. But what if we wanted to collect data from devices? So say a thermostat on the network or a access control system. Well, we provide software for building a ThingPoint. So a ThingPoint is a little server that sits out on the network which the EMS server is able to connect to. The ThingPoint is also connected to the various devices. So that might be smart devices such as watches, thermostats, weighing scales, and so on. So effectively, the data collected from those devices is fed into the ThingPoint, and the ThingPoint can then make that data available to the EMS server. The way that it works is something like this. You have your EMS server, and we'll say that's running on IP 192.168.170, and it's on port 8080, for example. And we also have a ThingPoint. Now the ThingPoint is actually also a server. So it's sitting there running on a different IP address on a different port, so we'll say 8081, and it's got data coming in from all of those devices sitting there waiting to be collected. So the first thing the ThingPoint does is it connects up to the EMS server as a client, and it sends in a registration message, something akin to saying, hello there, I'm a ThingPoint, I'm called Edge Devices, and I'm available on this IP address at this port number. Once that registration is done, the EMS server knows where to go find its data. It knows that it can call out to the ThingPoint. So from that point on, it treats the ThingPoint as a remote server, and the EMS server acts as a proxy for the clients. So let's go ahead and take a look at how we build a ThingPoint. So I'm going to start building a ThingPoint by building the Arduino hardware. Don't worry if you're not able to follow along with this part of the demonstration. The first iteration of the ThingPoint that we build will use dummy data in place of the actual device. So I've taken this joystick component from the MakerFabs kit, and I've wired it up to the Arduino Nano, which is going to collect the data from the joystick. The wiring is very straightforward. I've connected the ground and +5 volt pins on the joystick to the respective ground and +5 volts on the Nano. I've then also connected up the X and Y axis to A0 and A1 respectively. That's the analog inputs, 0 and 1. And then I've connected the switch on the joystick to the digital pin D2 on the Nano. Okay, I've included a project called Joystick Packet Serial under the Joystick directory of the source code for this session. And I've opened that project up here in Visuino, and I'm going to deploy it out to the Arduino Nano. So I'm going to come up here and go Arduino, and actually let's send it to the Arduino IDE. You could use upload, but I'm going to open the project up in the Arduino IDE. And I'm just going to make sure that the IDE is set to the correct port, which it is, COM3, and I'm going to go ahead and hit upload. So we're now compiling and uploading this sketch, which is going to receive data from the joystick and transmit that on the serial port, in this case the USB port. Okay, so with the uploading done, I'm now going to test that this is working. I'm going to do that by selecting the correct COM port in the Visuino terminal window. I'm going to set this up for 9600 baud rate, and the format I'm going to drop to packet 1, and then I'm going to go ahead and connect to my Visuino. If I switch over onto the scope and move the joystick, you can see that the scope is reading the X and Y axes, and if I push down on the controller, the little blue line there, that represents the button being pressed and released. Okay, so we know that the Arduino is working, so now let's get this data into a Delphi project. So also included in the source code for today's session is a project called Scope, which is a Delphi project. I'm going to go ahead and open that up, and we can see that we've got a scope control here and a couple of other components which I'll look at in a moment. I'm going to go ahead and run this project, and as I press directional controls on the joystick, you can see the scope reading my input and the button. And if you look at this edit box also, you can see that it is changing as I move one of the axes on the joystick. So this is reading out the actual value of the analog position on that particular axis on the joystick. Okay, so now that we know that that's working, let's go ahead and build an application which just grabs the X and Y axis data and displays them in edit boxes. So I'm going to go File, New, and VCL Forms application. And I'm going to grab a few components here. So I want the comport component from the communications lab, and I'm also going to put in an unpacket. So this is taking the packet data that's coming from the Arduino device and decoding the packet. I'm also going to get myself a generic real, TSL generic real value, and I'm actually going to take 2 of those to decode the inputs. And then I need somewhere to display the data, so let's create a couple of edit boxes as well. And we'll give that a little bit more length. And I'm going to come over to the caption property and just empty these out, or the text property rather. Okay, and now if we switch over to the Open Wire tab, we can start to wire this up. So I have my comport, and the data from the comport needs to be fed into the unpacket component, and the unpacket component needs to know what's coming in. So I'm going to edit the elements, and we actually have 2 binary floats coming in. Those are the X and Y axes, and we have a Boolean for the button. Now we're not using the button in this application, but I just want to make sure the packet understands what we're decoding there. And then I'm going to bring the 2 real value controls or components up, and I'm going to bind the output of each of these 2 floats to a real. So that's the 2 reals bound. Now back on the form, if we take a look at the generic real value 1, we can see that it has an event on processed data. So I'm going to go in and put a handler into this event. It's going to be edit1.text is equal to float to struct, and we'll use the out value parameter which is being passed in. So that's going to give us our access value. I'm then going to repeat this process for generic real 2. But in this case, I'm going to feed the data into edit2. So let's go ahead and run this application. And it's not working. Okay, what did I miss? The comport is connected to, so it needs to be on COM3 for my device. Okay, let's run that. And we have data showing. So as I move the controller around, we can see that these 2 data points are changing. So we now have some data coming in from our device. Let's see how we build a ThingPoint to push that data up into our EMS server. Okay, so to build the ThingPoint, I'm going to start a new multi-device application. Now you don't have to start a multi-device application. You could use a VCL application, or if you want to create the components at runtime, you could use a command line or even a Windows service application. But it's just convenient for me to be able to drag and drop these components so that you can see them. So I'm going to start with a visual app. And I'm going to go ahead and save this all off right away. And I'm going to put it in a directory named EMS ThingPoint. So you can go ahead and download the subversion source and find this project as EMS ThingPoint. Okay, so we need 2 components for our ThingPoint. We need an EMS provider, and the provider is effectively the client component for our EMS server. So this is what's going to connect up to the EMS server, do handshaking, register services, and so on. And we then want an edge service provider, or an TEMS edge service, and this is going to effectively be the server-side part of the ThingPoint. So this is going to make our ThingPoint available to be accessed across the network as a server. It's going to be listening. So in the EMS provider, I'm going to go ahead and set the address of my EMS server, which on my machine is localhost. So on your setup, you may have your ThingPoint somewhere else on the network. You need to put the IP address of the EMS server in here. And then for the port, well, the EMS server I'm using is the developer edition. It's on port 8080 and it's HTTP protocol. Then for the edge service, I need to make sure that the provider is bound, because the edge service is going to advertise itself as being available through this provider. One property which we can't change but is published and looks like it needs to be set is the listener service. And this is published for various runtime typing reasons, but we can't actually set this here. We're going to make use of this in code. We also need to set our module name. So I'm going to call this EMS ThingPoint, and that's what we're going to register our edge service as. Okay, so now we've set these properties up, let's see what we can do with these components. The first thing I'm going to do is use the EMS provider to make sure I can do a handshake with my EMS server. So I'm going to go ahead and drop a button on my form here, and I'm going to set the text property to handshake. And what this means is that I should be able to do a test call to the server just to make sure that it's there. The way I'm going to do that is I'm going to call EMS provider 1 app handshake, and then I'm going to put in an anonymous method, and the prototype is procedure, what was it? It was a constant AOG T JSON object. So effectively the app handshake, when it returns, will call our anonymous method and pass in a JSON object. And all I want to do with that object is show message, and I'm going to say tjson format this object as a pretty string for me, and I'll pass in a obj. Okay, now in order to use that, I'm going to need to put in system.json, and I'm also going to need rest.json in this unit. Okay, let's go ahead and run that application. And there are errors. What did I get wrong? System.json is redeclared. Okay, that's already in there, so I don't need to add it. Okay, so with my EMS server running in the background, let's go ahead and pull that up for you. I'm going to go ahead and hit handshake, and you can see that I got the version and EMS data come back. Okay, good. So that means that our ThingPoint is able to see the EMS server across the network. So the next thing we want to do is register this ThingPoint so that the EMS server knows about it. So first things first, I'm going to go and look in my EMS management console, make sure that I'm connected, do a refresh under modules, and there is nothing registered. We need to get our ThingPoint registered in here. Okay, the way we do that is I'm going to put a new button on my form, and I'm going to set the text to register. And then I'm going to save myself a little typing here and copy paste some code in. Okay, so the first thing we're going to do is we're going to use the EMS edge service and set its listening protocol. Now I'm setting the listening protocol to HTTP. You remember that property that I said we couldn't set? Well, that's because the property has been created for us. It's this EMS Edge Service 1 listener service. And this listener service is basically a pluggable protocol handler. And so I'm going to cast it as a custom EMS Edge HTTP listener. That's because I'm using the HTTP protocol. And I'm going to set the host address to localhost. Now that actually, on this occasion, this is not the host address of the EMS server. This is the host address of the ThingPoint. So again, if your ThingPoint's off on the network somewhere, put a suitable IP address or host name in there so that the EMS server knows where to go look when it's looking for the ThingPoint. And the same thing is true with the port number. I'm using 8082 because my EMS server is on the same machine as my ThingPoint, and it's already using ports 8080 and 8081. So I'm just going for the next available. And then I'm going to go ahead and call register module. So that's going to register this module with the EMS console. Let's go ahead and give that a test. And I've got some errors because I need a user for that, which is this EMS hosting HTTP listener. Okay. So now I'll go ahead and bring my EMS console back. I'm going to test my handshake again. We're all good. I hit register, and if I do a refresh over here, I get EMS ThingPoint, and it's showing me that it's registered. Most importantly, this EMS server now knows localhost 8082 is where my ThingPoint is at. Now, if you'd like some feedback when your EMS Edge service is registered, we have the events on registered, and we also have on unregistered, so you can go put messages or log messages or what have you in there. I don't need to do that. I've just registered my module. So the third thing that we need to do with our ThingPoint is add a resource to it. Now, first thing I'm going to do is add in a special unit here, which I'm going to come back to, and this is EMS resource types. And I'm going to come back and show you why this is added in. In fact, I'm going to comment it out so that I can show you what the problem is if you don't remember to include that. So remember that's there, put a pin in it, we're going to come back in a moment. What I need to do now is build up a class which represents the resource that I'm going to be publishing. Again, I'm going to copy paste this because I don't really feel like typing it, and this is my class. So I've got a class here named tResource, and it is publishing a get method. And this get method should look relatively familiar. Ignoring the context property for the moment, we have a request and a response. So as you saw when we built an endpoint earlier, it's a request response system. This is how REST works. So all we need to do is look at the request, decide what the EMS server is asking us to do, and provide the appropriate response when we build a handler for this method. Now these parameters are going to be passed in by the ThingPoint Edgeware code, so we don't need to worry about passing them in, we just need to handle them. You'll also notice that I have method info on, method info off. Effectively, I want to make sure that there is runtime type information for the tMyResource class, because in order to publish this, the EMS software is going to go off and look at the runtime type information. And I don't want this resource to be registered as tMyResource. I want to give it a more friendly name. So I've put this attribute, resource name, and I'm calling it Joystick. And that's because this is going to return the data from our Arduino joystick eventually. And finally, I'm using +m. It's just another directive to ensure that runtime type information is produced as needed. Now with this class, I need to implement the get method. So let's go ahead and put an implementation in here. Again, let's save some typing. I'm going to go ahead and do some copy pasting here. And let's look at what we have. So result data, I'm just creating a result type of JSON object. So I'm going to create an instance of that object, and then I'm going to add two pairs, so two properties to the object, x-axis and y-axis. Again, we're going to be getting data from our joystick component, so I'm going to pass them out as the x-axis and the y-axis values. And then I'm just passing in some dummy values right now of 10 and 20. And finally, this is the bit where I'm sending my response. So just as we did with the endpoint, a response.body.setValue, I'm passing in a JSON object to be decoded, and I'm saying true. That means that the ThingPoint code is going to take ownership of this object. We don't have to free it. That's going to be handled for us. And the final thing I need to do is, now that we have our resource, I'm going to go ahead and set up an initialization section. And in here, all I need to do is register resource, the type info of tMyResource. So what that's going to do is, at the initialization of the unit, it's going to go and look at tMyResource. It's going to use all the runtime type information and this attribute to name it, and then it's going to publish that as one of the available service options for the component. Okay, the next thing we need to do is to set our endpoint to active, or our ThingPoints to active. By doing so, the EMS server will be able to call it. So let's go ahead and grab a button, and we'll set this to activate. And one more time, I'm going to do some copy pasting here. I'm actually going to set two things to active. So the first thing I'm going to do is make sure that the edge service itself is active, and then I'm going to make sure that its listening service, so its server component, is also set to active true. Now before I run this, I'm going to go back to my EMS management console, and I'm going to manually delete the one that I've already registered. The reason is I'm going to have to register again, because when I registered the first time, we didn't have our resource in there, and so as far as EMS is concerned, this ThingPoint doesn't have any resources. So rather than build the unregistered code, I'm just going to go ahead and use the console to delete that out. So let's go ahead and run this code again, and I'm going to show you the deliberate mistake. Oh, actually here's a non-deliberate mistake. So I need to be including EMS resource API. And that gives us the types of T endpoint context, T endpoint request, and so on. So okay, let's go ahead and run this. Excellent, it linked. So I should still be able to do my handshake, but when I try to register, I should have a fault. Okay, so what's going on here? Well, the code that's necessary to register the runtime type information is actually inside of EMS resource types. Now, the application will still build and run without this users included, but as you've just seen, it will crash when you try to register the resource. Make sure you have this unit users and you won't get that error. So let's go ahead and try again. Going to go ahead and register, and this time it's successfully registered. So if I take a look back in the management console and do a refresh, we can see EMS ThingPoint has been registered. Okay, so we have our ThingPoint registered. The next step is going to be to activate it. So I click on activate, and our ThingPoint is now enabled so our EMS server can see it. And so we can go and access its data. I'm going to bring up a browser here. Let's see what I have in my paste buffer. Okay, so I've gone ahead and called our our ThingPoint, and I've got back x-axis and y-axis. So let's take a look at the URL here. We're calling localhost 8080. That isn't the ThingPoint itself, that's actually the EMS server. We're then asking for the EMS server's registered edge modules and looking at our EMS ThingPoint, and we're requesting its joystick property. So what's happening is when we call for the registered edge module, it's going to go and find our EMS ThingPoint and it's opening a connection to it. It then requests the joystick data and sends that back to us. So effectively the EMS server is proxying the ThingPoint. The important part about that is you could have multiple ThingPoints across your network. So if you have let's say a factory floor with a number of Bluetooth tracking beacons, well, Bluetooth doesn't have a very large range, but you could have multiple ThingPoints within range of each of them. So this would give you the ability to collect their data and make that all available at a central location in your EMS server. Let's take a look now at how we modify this ThingPoint to collect the actual data from our joystick sensor. Okay, so we now have our ThingPoint and we've seen it working. So let's go ahead and modify this ThingPoint to use actual data from the joystick. I have the joystick plugged in, and you've seen the code to build this to get the data from the joystick before, but I'm just going to run through it real quick one more time. So let's grab a COM port component and put that on the form. On this occasion, we'll make sure that that is set to COM port 3. Okay, and we'll have a unpacket component, and that we're going to bind to the COM port shortly. Then we're going to have a generic real value, and in fact we need 2 of those. So we've got 2 generic real values. And then in the code itself, actually let's go and do the wiring up first. So the COM port I'm going to feed into the unpacket. The unpacket needs to have some elements to decode the data that it's getting. So I'm going to go ahead and use 2 binary floats. and there's the binary boolean coming from the joystick button as well. We're not using it in this application, but we need to make sure that it's in there. And then I'm going to go ahead and bind up the float to the real, so they're bound. And then if we switch back to the designer, we can come in and set the on-process data event for generic real, actually to do 1 first. And what I'm going to do here, I'm going to use a couple of just unit global variables. So I'm going to have x-axis is a real and y-axis is also a real. Now obviously you could put this data anywhere you like. I'm only going to be grabbing the most recent value from the joystick into these two variables. If you were reading data from a sensor, you could of course cache that data, and when the EMS server calls the ThingPoint can respond by sending all of the data up, or all of the data since the last fetch, or what have you. But we're just going to cache the latest value right here in X and Y. So back down in my event handler, I'm going to say that the x-axis is equal to the out value, the most recent out value from the controller. I'm going to take a copy of that because we're going to do the same thing again for the y-axis. So we have the x and y values, and then down here in our get method, well, instead of passing in a JSON number, this time I'm going to change this to a float to str x-axis and get rid of our dummy value. And then I'm also going to pass in a float to str on the y-axis. Okay, so that's our module. Let's go ahead and build and run it. Okay, so I go ahead and activate, and that's activated my module. And now if I pull up our web browser here, and paste in our address, we're going to go off and take a look at the joystick reads. So there we have the joystick data coming back out, and I can go ahead and refresh this while moving the controller, and you can see that I'm altering the X and Y axis values. Okay, so our ThingPoint is working. In the next part tomorrow, we're going to take a look at how to document the endpoint that we built using YAML, and we'll also look at how YAML is used to document the ThingPoint that we just built. YAML is a documentation format which we can then hand over to, say, a web developer or a .NET developer, and have them access our services from their own preferred language. So we'll take a look at some examples of how we do that using JavaScript and C# tomorrow. Thanks for watching. My name's Craig Chapman.
Were there any of the questions you already answered here, Craig, that you want to elaborate on?
Sure. I wasn't sure that I fully understood all of the questions. I'm sorry if you pick up noise behind me, by the way. I think the neighbour's having their lawn done. So, yeah, one of the questions that I found interesting was what are the limitations of RAD server? And from a technical standpoint, you can do pretty much anything that you can do in a regular application. I mean, what you have to remember is that you are in a server client setup. So, yeah, you're going to have the normal limitations of server client. One thing in terms of how the product is built, however, is it's really targeted more at corporate backend. It's not targeted at mass market applications so much. You can do mass market with it, but you may need to have a slightly different licensing agreement to do that.
Right. And we do have great promotions around RAD Server from time to time that might make it more suitable for that sort of thing. But you're right, it is really targeted at the idea of having the individual logins where you're maintaining the accounts by user like you would in a corporate backend. There's a few questions here I see about the Linux support, Apache in the future. That is something that's on the roadmap, and there is a, for those of you that are on update subscription, you can get on the beta for the next release. That's one of the great benefits of being on there, and you can see what's coming. So if that's something that's really important to you, definitely do get an update subscription. If you're on update subscription, you can certainly get on the beta and start finding out what's coming in the future. So stay tuned for that, or I guess not stay tuned for that, but definitely do take advantage of that if that's if you're wanting to see what's going on in the future. That's your crystal ball right there. Update subscription.
Yeah. So the other thing is, I know that support for Linux Apache modules is on the roadmap for RAD Server, That doesn't necessarily mean that RAD Server support for Linux will come out at the same time as RAD Studio support. I believe the intention is for that to happen, but in software dev and monitoring QA and everything, there's a possibility that that won't happen in sync. Don't have dates for that yet, but I know that that's the intention.
Yeah, it's interesting being a software developer because sometimes we're the releaser and sometimes we're the releasee, right? Sometimes we're like developing software and saying, well, it's more complicated than we thought it was going to be. That's going to be late. And other times we're like, no, I don't want it late. I want it now. So it's the nature of the beast, I guess, right? So there's some questions here about installing the SAPI module. There's the doc wiki has some information on there. I thought I'd seen an article that Marco Cantu had done, but I could not find it. And I probably did a video on it, but it was years ago, I think.
Yeah, so I wanted to disambiguate actually really quickly, just in case there's any confusion. So EMS Server is actually the piece of software which hosts your APIs and provides the analytics data. RAD Server is the name of the product in which EMS is a major component. So EMS has existed a little longer than RAD Server as a product. So some of the material for installing it is still named EMS. It's not been updated, but it's still perfectly relevant, and the product is still named EMS under the hood. So.
Yeah, I think it probably will. It's probably going to be a little confusing for a while because of that, but I don't know that there's any plan to change EMS to be RAD Server. It's just sometimes.
No, I think EMS is retaining its name, but RAD Server is the product bundle which includes EMS, but it also includes Bluetooth beaconing and some other functionality and components as well. Includes interbase licenses and things like that. So EMS as a component is a component of RAD Server.
Yeah, kind of like how what was it? I guess Delphi is the product, but Object Pascal is the language used in Delphi. But sometimes we call it the Delphi language to be more specific.
I mean, my usual disambiguation for RAD products is, hey, so Delphi and C++ come with the RAD Studio IDE, but RAD Studio is a product bundle which includes Delphi and C++. So yeah, it's kind of akin to Delphi being a component of RAD Studio.
Exactly. Very cool. Well, this was great. Lots of fun. It's always exciting to start seeing things being put together like this where you're combining different parts. And yeah, that's fantastic. Boy, anything you wanted to add today besides pointing out the missing header bits in for Craig?
Oh no, I thought that was a very good presentation, and congratulations, Craig. You did quite a good job. And please thank your neighbor for the noise background that he provided for you.
Yes, the live timing, So
I can't tell you how often that's happened to me where I'll be working on something, and as soon as it's time to either record a video or do a webinar or something like that, all of a sudden the neighbor's lawn crew shows up and starts doing the lawn, and it's like...
Actually, timing was just perfect because I had a new internet connection installed today as well, and timing to get online was just all went perfectly. And then, of course, the neighbor gets their lawn mowed. So
you're going to keep your DSL and your cable together and use one as a backup? Is that the idea?
No, killing DSL. DSL's out of date, pointless.
Okay, well, fantastic. This has been day 3 of the Internet of Things Boot Camp, showing how to combine the Internet of Things components into a ThingWare, Edgeware, EMS, RAD server stack where you can start sharing data. I still think it is so amazingly cool to think about sharing the position of a joystick over a REST service that could be exposed on the internet to anybody who could come out and see the position of the joystick there. it just seems really pretty cool to me. So that was today. Tomorrow we're going to have expanding this out with YAML and Swagger so that you can interop with other people and other systems so that they can consume the data from your Internet of Things solution. So thanks so much, Craig, and everyone for joining us today.
And just I wanted to point one last thing out just before you go there. So I know that in the demo I'm basically consuming data from an external device. That's what I'm aiming at. But I'm calling the get method. If you would call post or put, you can also send data back to the device. So one example that I give is of access control. You can have a pin pad read data in, have your EMS server make the decision about authentication or access, and then send a message back through a ThingPoint to a servo and open the door, or whatever it might be. It might be a monitoring system for engineering equipment or what have you. So although I'm only covering the reading data, don't be fooled into thinking that's all you can do. You can write as well.
Yeah, that's a really good point. It's always kind of tricky when doing these presentations for the what level of to show, because you can always do more, and then it gets complicated. But at the same time, if you show it too easy, you don't want people to assume that you can't do more than that. All right, there's some questions here about URL for the resources to publish. That's up on the screen right now, right? That chapmanworld.com/IoT Boot Camp days 3-4.
Yes, and the bit link at the bottom there, which is shorter, is for the same page. So
yeah, you can check that out there. As far as Delphi for Raspberry Pi, there is a great blog post. Let me share that one here. Fixed by Code by Stefan Glinke about Neeland. Sorry, too many names. I get confused. Here's one on how to do Delphi on Raspberry Pi 3. There may be other stuff in the future, but there is certainly an option available today. And there we go. Yeah, so great. It would be interesting to have that where you could maybe make a game. Yeah, actually, a long time ago, I had a system set up where you could build bots in a script version of Delphi, and those bots could then battle it out in Unreal Tournament 3. So what I do is a session where people could connect through these bots, and then I would be hosting it, and then everybody would see up on the big screen in a conference room. But I think it'd be cool to take that and move it to the next level, which would be a REST service. And so I'd just expose this REST service, and people could make bots that could then interface through that REST service and control the bots on the screen. So, and then maybe we could do it remotely. You could do like a Twitch, except everybody would be writing bots to do it. I don't know. Maybe something we could do something like that in the future. Question about link for days 1 and 2. Sure, I'll get that for you here. embt.co IoT Boot Camp.
Go ahead and post that, and if you miss it, it's also on my blog post. So grab mine, and you can get the link for the IoT Master blog post.
And we'll get the links from here to Craig's as well. I did. Day 1 has actually been expanded. There's a lot of links on there. Oh, and we need to link to Boyan's got a blog post up as well, which I don't have a link to as well, which is at labpacks.blogspot.com is his blog. And he has all of his Visuino projects up there from day 1 and day 2 for you to download as well. So lots of resources, and I'm sure on Friday we'll be tracking down any missing resources and putting them online and fixing all the links and stuff like that. But the main page at embt.co/IoT Bootcamp 2017, that's designed to be the hub page that will point to everything else. So you can find that there and find the resources you're looking for. Thank you so much, Boyan and Craig, for all that you've done to make this a success so far, and thank you to everybody for joining us. And I think we're at the end of the questions.
All right. Thank you, Jim.
All right. Bye, everybody.